Welcome everyone to the Evident Proof demo. My name is Matt Roden. I'm the CTO of Evident. And today I'm just going to take you through a short demo which shows you some examples of usage of the platform, walks you through the platform itself, and gives an indication into the terms we use and how developers interact with the platform and so on. So without further ado, I'll launch straight into the Evident Proof dashboard, which you can see on my screen now. So if we take a look briefly at what Evident Proof does, Evident Proof is a platform to allow organizations and individuals to store data and proof of data immutably on the Evident blockchain. So what do we mean by immutable? We mean that the data is not tamperable, not hackable, cannot be changed. And we can demonstrate that data that was stored on our platform, or proof of data that was stored on our platform, was indeed stored at the time that the user said it was stored, in the exact format and to the exact data specification that the user said it was stored in, and that the data matches exactly what is being claimed. So we'll run quickly through how that works in a life cycle. So developers come on to the Evident Proof platform. They can request an API key. An API key is effectively, well, here we go. Let's go and have a look. So an API key is effectively a key and a secret and a date generated. Effectively, this allows developers to interact programmatically with the Evident Proof platform via REST APIs and our SDKs. The information required to hit one of these endpoints isn't all on this screen for security, so you require a key, a secret, your username. You can see all of those things, but you also require a service agreement ID, which you can get from the administrator of your tenant. So when we have an API key, as a developer, as an organization, or an individual, we can go and store data on the Evident Proof platform in what we call proof seals. What is a proof seal? So let's think about a contextual example and a real life one. So we have a client that uses our platform, and they use the platform to store data on safety equipment, so in particular respirators. And this particular client has a big problem with counterfeiting of products. So they want to be able to store proof data around their respirators to prove what respirators were actually manufactured in their factory and call out which respirators are fake, particularly in the case of when serial numbers have been copied and so on and so forth. So one piece of data about the manufacture of a respirator would be a proof seal. It is effectively a piece of data coming in, and we call this data evidence. That data is then hashed and converted into something we call a proof seal, which then goes through to be stored on the Evident Proof blockchain. So a proof seal bundle, which you'll be able to see down here, so we'll describe it a little bit more, is a bundle of data representing a logical thing or a logical record. And so in that case, the proof seal bundle is our respirator. So when I want to be able to prove the provenance of a respirator, I can request a proof seal bundle of that data. So hopefully that's not too confusing and I've explained it clearly. Any questions that you have as I go along, please put them into the Telegram chat. I am a technologist, and I will not always not always explain things in a way that all of the audience can follow. So I'm more than happy to answer questions to clarify. Okay, so what are all these things on the screen? So when data is stored on the Evident Proof platform, I receive back a receipt and an EPT token for my proof seal. Why do we receive a token? What is the point of tokenization? the point of tokenization is that when I go to request a proof certificate to prove the data that I'm saying is in my proof seal, I'm required to present that token along with my receipt. This allows direct interaction into Ethereum smart contracts. And this demo is not the place to go into that, but I'm more than happy to do offline sessions with people on that concept. Seal credits is purely the amount of credits I have to store proof seals on the platform as a developer or an organization. So I'm down to 84 proof seals. The rest of the data is basically analytics data on the activity on the platform. Okay, so we can go and have a look at some proof seals, and then I'll go into everything in a bit more detail. So here are proof seals. The schema is effectively where, being an IP address, and so on, when, being a date timestamp, the cross-reference. This is a client key. This is something that means something to the client, not to us. So this is effectively how this data is linked back to the source data in the client's database. This can be a compound key, a single primary key, whatever. A key and a value. This is the contents of our proof seal. In this case, this is arbitrary data. I'll go into explaining what this is in a second. And value we've hashed. This is the data that actually means something to our client. And then the seal, which is a hash of this data, and this is what actually gets stored on the blockchain. So it is through this data that we prove the integrity and immutability of the data on our platform. So let's look at a real example. We have a client who is the largest provider of government taxi licensing solutions in the UK. This client needs to be able to prove the provenance of the journey of a taxi license being issued. So why is this important? Well, it was only a month ago. This happened after we implemented this solution for this particular company, but only a month ago there was an article in the Guardian in the UK saying 150,000 taxi licenses in the UK had been issued in error to drivers with criminal convictions, drink driving convictions, driving bans, you name it, they had it, and no one could quite work out how they got there. So how do we address that problem? Okay, so we're going to go on to another tab here, and effectively what this is a representation of one of the workflows in the client software. We can't show you the client software itself, but we can represent what it is they're actually doing within a condensed workflow. So this workflow concerns itself with the initial registration of a taxi license. Of course, in the real system, this is 10, 15, 20 workflows. In here, we've condensed it into one. And as I go through, I'll explain the kind of intricacies the client actually has on their system. So effectively, this is a separate site representing the client system, and this is integrated on the back end to the evident proof API using the API keys that I showed you that have been generated. And every time we generate a taxi license on this system, that data will be sent to the REST APIs of the evident proof platform and stored through a proprietary mechanism involving a public chain, a private chain, Ethereum, smart contracts, in an immutable way. And we're going to show the journey of proving the immutability of that data. Okay, so we're going to create a taxi license. Let's go ahead and do this. Good. Right, so we're going to put in a name. Let's think of one we haven't done before. There we go. And we're going to say that the license is active. We're going to say we performed a criminal record check in the client's actual system. Of course, all the evidence of that criminal record check is stored as a proof seal per check. So we're talking police systems checks. We're talking the certificate that is provided as part of that check. who did the check, when was it done, and so on. And all of that data would be stored as part of this record. Driving license number, let's put something in UK format roughly. Again, in the client's actual system, they have an upload driving license document field and various other evidences to prove that that driving license is a valid driving license. Identity check. Again, there are mechanisms for performing identity checks, be it credit reference agencies and so on. In the client's actual system, they are storing every single proof point within that workflow to make sure there is no dispute on what was carried out, and are there driving offences or not. And we're going to say there are not in this case. Okay, so we're going to create this. Okay, so now we can see this license created. Okay, so let's then go back onto the evident proof platform. We know from what I've said that this data is submitted through to the evident proof platform. So we're going to go on to here, and we can see here that this is the new license, and we can see that by the timestamp. You can see the local time where I am is coming up to 2:15. Here we are. And we're going to go and view this record. What did we submit to the platform, and what is now the workflow for proving what we submitted to the platform? So we call API request dispatches. This is language that any of you who have read our white paper will recognize. So we have a dispatch ID, we have a where. I'm running this locally because I had some internet issues this morning, but this is an IP address. When, so the timestamp and the actual evidence itself. So the cross-reference 53, you will have noticed that was the ID of my record in my system. It's a fairly noddy example. So again, this would be potentially a long compound key linking back to some source data in a big enterprise system table. In this case, it is a one-to-one relationship. Key, new license, fairly simple. Value, you can see any of you in the software development community will recognize this format of storing data as JSON. So we have a license holder, a criminal record check, driving license number, identity check performed, driving offences, and so on. And so this can be this long, it can be a single field, it can be the works of Shakespeare. It really doesn't make a difference to our system, apart from on data storage costs, of course. If you choose to store the actual source data with us, again, this isn't the forum to go into the mechanics of that. I'd be happy to do detailed offline sessions with anyone who's interested in talking more about data storage mechanisms. Effectively, the reason it doesn't matter is it always gets condensed down to this size seal. So we really aren't worried how big the data is. This is the way hashing mechanisms work. Happy to describe that to anyone at any point. Okay, so we stored that data. What happened after that? We got a receipt. So you can see receipt success true, and we can see we've got a receipt ID. Why do we need a receipt? What is this? What are we going to use it for? Good questions. When we programmatically send this data to the evident proof REST APIs, this is what is returned to us. What do we do with it? Okay, so we have a record in our source data table in our enterprise system or our small business system, whatever it may be. And at some point, someone's going to say, I need to go and prove this particular record. So if they do that from the perspective of your source data, then of course you could go and figure out where your evidence record is in our system with this long compound key. However, the easiest way is if you store a receipt against that record in your source database, if that is viable for your database structure. In doing so, you then open the doors to getting a proof certificate more easily. So what is a proof certificate? A proof certificate is what we can now request, let's say a year down the line, when one of these taxi drivers, someone is claiming that they don't have a license. We now need to prove in a court of law, for example, that that taxi license was issued correctly, that the checks were performed. And if it still turns out that that driver did not have a driving license, we can go back and show, okay, here's what we did, here's every piece of evidence in the line of business application, and here's how we performed it, and quickly get to the bottom of, okay, right, it was a fake document, or so on. So it's not that we're saying that the data you put in is going to be valid. It's that we're saying we can prove whatever you put in. So it's proof of evidence, evident proof. Okay, so we're in a court of law. We need to prove to the court that that this data was stored immutably. We're using blockchain protocols. Any expert witness could go in and argue the immutability of Ethereum with no problems. But where do I get all those references from? How do I locate this data on the Ethereum network, and so on? Well, I'll need a proof certificate. I'll need a report. In this system, you'll see in a minute, we just output the data in a raw form. We have large enterprise clients who have tailored proof certificates, which are PDF documents in a format signed off by their legal team, their governance team, to say, yeah, okay, this is how we are going to prove this data. So let's do a new proof certificate request. What's happening in the background is the system is going to check the private chain. It's going to check the hashes on the public chain, and it's going to come back and give us this proof certificate. So we can see we've sent a request. Here's when we sent it. We use some tokens. Again, tokenization, probably not the time to go into it, but anyone who's wanting to deep dive in this can come and give me a shout personally anytime, and I will talk you through how that works. And out the other side comes this certificate. Okay. Here are the fields we are showing on our proof certificate. Depending on the organization, the enterprise, through a consultation process, we can give you as much or as little data as you need. We can show you what virtual machine or what server the data went through to get to the Ethereum network. We can show you all of the IP addresses involved. The possibilities are limitless. In this case, we show you the transaction ID from the Ethereum network. We're masking it here because this is a demonstration, but effectively take this transaction ID, go to the Ethereum network, and you will be able to prove beyond doubt that the data was stored in an immutable way. Why? Because within this transaction ID is this seal is this data, the transaction has a timestamp, and all of this data is encoded within that transaction. There is no way that this data can be argued against. So that is evident proof. Probably that's about long enough for today. Anyone who has any questions, please post them up now. Brian, I believe, is in the Telegram channel right now, one of our fellow co-founders, ready to answer questions with me. Also, Adrian Clark will be available to answer further questions in the channel, and I'm always available directly on the channel, or you can DM me on Telegram. You can also email me. There is my email address. Good. Thank you for watching. It's been a pleasure.